Imagine an ordinary day near the end of the Cretaceous period, around 66 million years ago. A T-Rex is hunting across a sunlit plain. Its prey is terrified, not of the predator, but of the western sky. A light brighter than anything ever seen is racing toward Earth. It's not a storm. It's not a volcanic eruption. It's something that will change the entire planet. A massive asteroid. The Chicxulub asteroid measured between 10 to 15 kilometers in diameter and struck Earth at over 70,000 kilometers per hour. When it impacted what is now the Yucatan Peninsula in Mexico, it released energy equivalent to 10 billion Hiroshima bombs. In seconds, the impact zone vaporized, leaving a crater over 150 kilometers wide and dozens of kilometers deep. Shockwaves radiated across the planet, triggering earthquakes, tsunamis, and widespread volcanic eruptions. But the impact itself was just the beginning. The true devastation came afterward. Dust, sulfur, and carbon from the explosion and global wildfires rose into the atmosphere, forming a thick shroud around the planet. Sunlight couldn't penetrate. Global temperatures plummeted. Within weeks, the Earth plunged into a nuclear winter, cold, dark, and deadly. This catastrophe devastated the ecosystem. Plants could no longer photosynthesize, forests withered, herbivores lost their food, and as plant eaters began to starve, predators like T-Rex ran out of prey. The food chain collapsed from the bottom up. Even though T-Rex sat at the top, once the base crumbled, it had no way to sustain itself. To make things worse, T-Rex was enormous and required massive amounts of food daily. Under normal conditions, it was an apex predator. But as animals around it died off and prey became scarce, its size turned into a liability. The bigger they are, the harder they fall. Especially in a world suddenly deprived of resources. Interestingly, scientists believe T-Rex didn't die instantly after the impact. Some individuals may have survived for weeks or even months. The last T-Rex fossils are found just beneath a thin layer of clay enriched with iridium, the chemical fingerprint of the asteroid, showing the species lived right up until the mass extinction. So why didn't it pull through? One theory asks, what if a few T-Rexes did survive the initial impact? Perhaps some lived far from ground zero, in regions less affected. Maybe a few scavenged corpses. With their exceptional sense of smell, T-Rex could easily locate dead animals killed by the cold, fire, or famine. But even if they could scavenge, the supply wouldn't last. Once the bodies were gone, no new prey emerged. Without the ability to adapt quickly, T-Rex faced a slow death, not from injury, but from starvation and cold. Juveniles wouldn't survive in such a harsh world. With no new generation, even the last survivors would eventually disappear. This shows that T-Rex didn't die because it was weak. It died because it was too perfectly built for a world that no longer existed, and too specialized to adjust to one that had changed overnight. Smaller animals, such as primitive birds, had the advantage. They could hide, eat a wider range of food, needed less energy, and reproduced faster. T-Rex, built for dominance, was now bound by its own success. That's the tragedy of the strongest. When the world changes too fast, it's not the most powerful who survive. It's the most adaptable. So, if the asteroid had arrived a few million years later, would T-Rex have had time to evolve? Could it have shrunk in size, changed its diet, or developed new behaviors to survive? In the next section, we'll explore exactly that. What conditions would have allowed T-Rex to truly survive the end of the world? If T-Rex were to survive the Chicxulub asteroid impact, it would have had to overcome a nearly impossible list of challenges. Earth was no longer the same planet it once ruled. Sunlight disappeared, the climate changed overnight, food chains collapsed, and prey vanished almost completely. To endure, T-Rex would need more than brute strength. It would require a specific set of survival traits, both physical and behavioral. The first major obstacle was its size. T-Rex was among the largest land predators to ever live, weighing up to 9 tons. With such mass, it required enormous amounts of food each day to sustain its energy. Once the ecosystem collapsed, the available food supply shrank drastically. A giant like T-Rex became extremely vulnerable in a world of scarcity, simply because it needed too much to survive during famine. However, T-Rex wasn't entirely helpless. One of its evolutionary advantages was its highly developed sense of smell, believed to be one of the most advanced among all dinosaurs. This allowed it to detect carrion from great distances. In the immediate aftermath of the impact, as fires, cold, and starvation killed off countless creatures, T-Rex could potentially survive for a short time by scavenging dead bodies. No need to hunt, only to locate the fallen. In addition, T-Rex could move relatively quickly for its size. Some estimates suggest it could reach speeds of 25 to 30, That meant it might have been able to migrate farther than many other dinosaurs, seeking out less affected regions where food still remained. Yet even if it reached such areas, how long those pockets of life could sustain it was uncertain. What T-Rex lacked was flexibility in its survival strategy. It was an obligate carnivore, dependent on fresh meat or carrion. It couldn't switch to plants. It didn't hunt in coordinated packs. It lacked complex problem-solving and behavioral adaptation. Most importantly, it reproduced slowly, producing few offspring that took years to mature. In a collapsing world, slow reproduction is a fatal disadvantage. In contrast, the animals that survived the extinction, primitive birds and small mammals, shared key traits: small size, omnivorous diets, fast reproduction, and the ability to hide. Some could burrow to escape the cold. Others could feed on seeds, insects, or anything still available. While T-Rex searched for massive corpses to eat, these small survivors only needed a few crumbs or bugs to get by. So if T-Rex wanted to survive, it would have needed to change, and fast. Suppose a small group did live long enough. They might begin to evolve: smaller bodies, lower energy demands, dietary shifts, increased intelligence, or even nocturnal behavior to avoid the cold. But these changes require tens of thousands or even millions of years, while post-impact environmental changes occurred within just a few years. In other words, the speed of Earth's transformation was simply too fast for T-Rex to adapt. If the changes had occurred gradually over millions of years, perhaps T-Rex could have evolved into a smaller, more adaptable predator. But with the world collapsing in months, even the planet's strongest predator didn't stand a chance. Still, a hypothesis remains. Perhaps a few T-Rex individuals survived in the southern hemisphere, or deep in sheltered forests with reduced impact. If they endured for several generations, evolution could have begun, leading to smaller, smarter T-Rexes capable of surviving in low-resource environments. They might have lost their title as tyrant kings, but lived on as shadowy predators bearing the DNA of a legend. However, no fossil evidence has been found to support this scenario. Perhaps even those final refuges weren't enough. Or perhaps T-Rex's legacy didn't vanish, but transformed, becoming part of modern birds, where the predator's instincts, speed, and precision live on in miniature. In the final part, we'll take this idea further. If T-Rex had survived, what would it have evolved into? A new apex predator, or something entirely unexpected. If by some miracle a few T-Rex individuals had survived the asteroid impact, the next big question would be, how would they evolve? Because in order to live in a world where the sun is blocked out, temperatures drop, vegetation dies, and the food chain collapses, T-Rex couldn't remain the same. It would have to change, from a giant killing machine into a smaller, more adaptable creature. Let's imagine the surviving T-Rexes found shelter in regions less affected by the impact, like dense forests in the southern hemisphere, where sunlight still managed to pierce through the clouds of ash. In such a place, the climate would be less extreme, and small creatures like insects, amphibians, or reptiles might still survive. In this new world, large size was no longer an advantage. It was a burden. Evolution begins with survival pressure. If the T-Rex offspring that happened to be slightly smaller had a better chance of surviving, they would pass those traits on. Over thousands of years, the hypothetical T-Rex population might gradually shrink in size, from 9 tons to just a few hundred kilograms, eventually approaching the size of today's large predators. But it wouldn't just be size, its diet would also need to change. From a predator that hunted large prey, it would need to shift toward scavenging, eating insects, eggs, and even soft plants. The teeth would likely change, from bone-crushing spikes to slimmer, faster, or even beak-like structures, better suited to smaller meals. Its hunting strategy might shift from brute force to stealth and ambush. In a darker, colder world, our hypothetical T-Rex might also evolve into a nocturnal animal with enhanced night vision, or perhaps a thin layer of feathers to retain body heat. Some scientists believe that early bird ancestors were small, feathered theropods, so why not a T-Rex descendant? With enough time, that transformation could be entirely plausible. Take it even further. After tens of millions of years, T-Rex could become something entirely new. Perhaps a large bird of prey, like a giant eagle or hawk. Or maybe a forest-dwelling creature the size of a chicken, surviving on speed and agility. Its legend could live on in a completely different form. However, this transformation could only occur if the environment remained stable long enough for evolution to happen. In reality, the post-impact world changed so drastically and rapidly that each new shift acted like a filter, eliminating all but the fastest adapting species. And only creatures with short life cycles, high mutation rates, and small bodies had the opportunity to adapt. T-Rex, no matter how powerful, had a long lifespan, slow reproduction, and didn't have the time it needed to change. The first new versions of T-Rex might not even survive long enough to reproduce, and so the evolutionary path was cut off before it had a chance to begin. Not because T-Rex couldn't change, but because it didn't have enough time. That might explain why we don't see evolved T-Rex descendants today. But instead, we see birds, quick, light, diverse, and smart. Some paleontologists even argue that birds are dinosaurs, and that the DNA of modern birds still carries fragments of the past, memories of the rulers of a lost world. So, if T-Rex had been given a few million more years, could it have coexisted with humans today? Could it have become the most intelligent predatory bird on the planet? Or perhaps a mysterious little creature, hiding deep in the jungle still waiting to be discovered? That's a question science can't yet answer. But one thing is certain. With enough time, T-Rex could have evolved, adapted, and written a new chapter in its legacy, not through dominance but through survival.